Okay, let's go over this practice to make sure you understood all of it. So basically there were 7 problems. So for problem number 1 here, x to the 15th times x to the 5th. Basically, I rewrote without that x in the middle, just because if we're using the variable x, it doesn't make that much sense here to put another x, in my opinion, as a math teacher. But you can use that dot, which is a little clearer. So if I have 15 in this group and 5 in this group, right, I'm basically totaling up how many I have. So it's going to be an addition situation where I'm seeing in this group I have 15 plus 5 more in that group means altogether I have 20 x's that I'm multiplying. This is the same idea but opposite, right? So multiplying means I add, which means when I divide I subtract. But I have to subtract from the side that has more. So I'm going to take the smaller one and basically move it up to subtract it from the bigger one, which leaves a 1 on the bottom. And then obviously 1 on the bottom. Hopefully you feel like comfortable just dropping that. You don't need that on the bottom. So x to the 12 minus 4 would be x to the 8th. Ooh, let's fill in a couple of these. 20 and 8. Okay, so the next problem is the one that we talked about yesterday in class. So this is one where you have one base and you have 2 exponents on it. So it's like a parentheses with an outside exponent. So this is where you have to multiply in. So this is really going to be 4 times 20, which gives you to the 80th power. Okay, this is a review of last week. So realistically, this is a fraction, right? And if I switch this negative exponent over the fraction bar, it's going to turn positive. Remember that example of the negative baby and how if the parent switches rooms, it will keep the parent the same, but it will switch the baby to the opposite mood. And if you take everything out of one side, you replace it with a 1. Same idea with the next question, except this time the fractions are more visible, which is hopefully a little easier to see that realistically if you were switching rooms, if you're switching sides, you're taking the piece that's in the denominator with that negative exponent and moving it up to the numerator, which really would turn that into b to the positive 3. And I can put that 1 underneath, but if you look through your answers over here, you're going to see that it doesn't put the 1 underneath because that's not necessary. So I wouldn't mark you wrong if you wrote that, but on a multiple choice situation, you're going to have to be able to drop that and understand. Okay, this idea matches this idea, right? Really, I'm going to be, if I'm trying to figure out what makes this true, I'm trying to figure out what do I need to multiply here to make it equal 64? Because it's going to be whatever 4 times n times 8 is, right? Because that really just means multiply those two. So really n has to be 8, right? So that this can be 8 times 8, which gives me that 64. And then finally, the last question was probably like a jump farther all of a sudden in difficulty, but not that bad. I mean, really, you're just matching pieces, right? So I have 2 regular numbers, and I have 3 bases that have an x. And so if we think back to what my rules were, yeah, first of all, notice I added parentheses around each term, each piece, because I wanted you to be able to see where one started and one stopped. So I put parentheses there. Realistically, though, what you have is you have 5 times negative 3, right? Because you would want to put those two together, those two that match. And then you also have x squared, x to the 4th, and x to the negative 7. So if I'm just like rearranging the order they come in. So the other thing that I would say is I would look at this as a fraction because I would want this negative exponent to move down. I just like getting rid of the negatives that way. So I end up, if I start simplifying these two together, the orange one's 5 times negative 3 makes negative 15, right? And then x squared and x to the 4th make 6 of those on top. So these two combine to make this. But then this one moves down to the bottom. Because if I want this negative to turn positive, it would be positive when it's moved into the denominator. And then just like what we set up here, when they're on opposite sides, you subtract them. I would subtract them here too, except that this time I have more in the bottom. So I'm going to leave the negative 15 where it is. That one has its own exponent, right? That one has an invisible exponent of 1, and it's positive, so I leave it. So negative 15 stays. And then if you're looking at 6 and 7 here, I would really have 7 minus 6, because I would take this 6 down since it's the smallest and subtract. So I end up with negative 15 over x to the 1. But I don't need to have the 1, because if you look on your answers here, it doesn't have the 1. Also notice that this negative sign that I put in with the 15 is out front, which is fine. So negative 15 with that x is really the same as saying negative 15 over x. So that definitely was more difficult. This problem was a challenge. How did you do? I hope you got that challenge question right. Good job.